Hey everybody, it's 123 Mr. B here, just doing our breaking math presentation here in the sunshine as it casts down in the evening sun of the mystery city that I'm sitting in right now. And this video is going to be about giving us a speed trick. Now, I showed you a bunch of work, but I want to give you some speed tricks. Now, here is this one. His has to do with complementary numbers. Now, complementary, of course, means things that go together, like ketchup and mustard, I guess so, or toast and jam and that kind of thing. So two numbers that go together to make something better. Well, let's look at our numbers. Who here loves doing our 7 times tables, or our 3s, or our 9s, right? Those are all less fun, per se, than skip counting by tens. I don't think it would be hard to have anyone disagree with that. Skip counting by tens is a lot easier than these guys, right? So how about complementing these numbers with something so that we can deal with tens? So I'm looking at this here. The complement to 7, of course, would be 3. The complement to 3 would be 7. The complement to 9 would be 1. Because if I was to put those together, just independently here, that'd be 10. Put those together, that'd be 10. Put those together, that'd be 10. And then, yay, I'm dealing with nice, happy numbers instead of ugly numbers that I don't want to touch. So this is quite simple complementary numbers to 10. But I want to look at bigger numbers, maybe complementary numbers to 100. Now, some of you will be able to see these right away, but others might not. For example, what's the complement to 31? What is the complementary number to 31? Now, I know a lot of people are going to say 79, 79, because if I put a 7 there and a 9 there, that makes a 10, and that makes a 10. And I like how you're thinking with that, but it's just not quite right. Let's check it out. 31, what's the complement to 31? Let's just start by picking an easier number. How about 30? If we know that the complement to 30 is 70, check this out. We know that's 100. If I add 1, so it's like I'm moving a chip to a different stack. If I add 1 to 30, I got to take 1 away from 70. So I really end up with 31 and 69 gives me 100. Okay, so the complementary to 31 is actually 69, not 79 like we might look and see right off the bat. Okay. Complementary to 57, I don't know what that is, but I know that the complementary to 60, because 60 is pretty close to 57, the complement to 60 is 40. So if I go 60 plus 40 is 100, and then I kind of go down by 3, so I'm going down to 57, I've got to go up by 3, so I'm going to have 43. So the complement to 57 is actually 43. If I add them together, I get 100, okay? Now, why on earth would we care about these complementary numbers? Especially when they're presented like this all over the map. Complementary numbers are going to set us up for a future subtraction trick called midpoint subtraction. Or, I don't know, that's my own title. It could be called anything. But anyway, what you do is you find numbers and then you put a common midpoint between them. You pick a number in between them, and then you simply rely on your knowledge of complementary numbers in order to solve that subtraction question. It will be this.